Have you ever actually stopped to think about the incredible journey your thoughts take just to become pixels on a screen? Seriously, every single email you write, every game you play, and every video call you make starts out as a human intention, and then it somehow has to magically transform into raw digital data. Well, let's dive right into this explainer because today we're going to explore the unsung heroes of our digital lives, the hardware translators.
Okay, here's our roadmap for this explainer. We'll be covering bridging the digital divide, the typing and pointing essentials, hands-on control with joysticks and touchscreens, digitizing our audio and visual senses, and finally, we'll wrap up with the future of input.
Section 1. Bridging the digital divide and the core problem of communication.
So how do you actually talk to a machine? A computer really only understands raw data. We're talking zeros and ones, electrical signals. But you and I, we understand movement, we understand sound, language, and touch. There is a massive, fundamental communication gap here. We literally need something in the middle to translate our very human actions into instructions that a machine can actually read.
And that is exactly where input devices come to the rescue. They are the tools for entering raw data and instructions into a computer system. Think of them as the essential translators. Because without them, a computer is really just a locked box of potential. These devices finally allow us, the users, to provide actionable data for the computer to actually process.
Moving right along to Section 2, the typing and pointing essentials, the absolute foundations of interaction.
All right, our first essential translator is the trusty mouse. But rather than just thinking of it as a plastic shell on your desk, think of it as an instant XY axis translator. It instantly converts the physical movement of your hand into a highly precise digital coordinate on a screen. And a typical mouse accomplishes this physical digital translation using 3 physical inputs: the left button, the right button, and that scroll button right there in the middle. And it's wild, because with just those 3 simple inputs, we unlock an entire vocabulary of digital commands. We're talking clicking, double-clicking, right-clicking, dragging, and scrolling. Each one of those physical actions sends a totally different, highly specific instruction for the computer to process. Now, if the mouse is all about translating spatial movement, the keyboard is our primary translator for complex language and raw data. It takes the physical act of typing and turns it straight into structured digital input. Here's a fun little piece of trivia for you. The layout we use globally to translate our keystrokes into data is called QWERTY, and it's simply named after the first 6 letters you'll find in the top left row of the keys.
104. That magic number represents the standard amount of keys you'll find on a typical keyboard. Though it is worth noting that if you're using a multimedia keyboard, you might actually have even more than 104 keys just to accommodate those extra playback controls.
To manage all 104 of those keys without going crazy, they function as a highly structured translation board divided into 5 distinct zones. You've got your alphabet and numeric keys for raw data, your cursor keys for navigation, and then functional or special keys to execute system-level commands and modifiers.
Okay, Section 3, hands-on with joysticks and touchscreens. This is all about direct physical control.
These 2 devices really represent a fascinating shift in how we bridge the gap. The joystick translates the analog, multi-directional tilt of a physical stick. Meanwhile, the touchscreen turns the display panel itself into the translator, reacting directly to the capacitive touch of our skin.
Let's be real, the joystick is an input device absolutely tailored for gaming experiences. It translates the physical tilt and push of the stick into in-game directional movement. Plus, it typically features an array of extra buttons specifically designed for gameplay, so it's completely customized for translating your rapid physical reflexes into a digital game. Then you have the touchscreen, which basically removes the intermediary hardware entirely. It makes the translation process feel almost invisible. What started out on smartphones has massively expanded to desktops, notebooks, and palm tops, allowing us to manipulate digital interfaces directly with our bare hands.
Section 4. Digitizing senses, audio and visual, capturing the real physical world.
Now we're getting into the devices that act as the literal digital ears and eyes of your computer. The microphone's sole job is capturing analog sound waves, while the webcam digitizes real-time visual streams directly from the physical world.
Working in perfect tandem, these tools translate our literal physical presence across the globe. They are absolutely essential for enabling everything from casual video chats on Skype, Viber, or Facebook Messenger, all the way to remote work and global online education.
But what about physical objects that aren't sound or live real-time video? Like, say, a printed document or a drawing?
For that, we rely on the scanner to step in and convert that physical medium right into enterable digital data.
And it's actually a remarkably straightforward mechanical function. Step 1, optical sensors capture the physical images or text. Step 2, it instantly transfers that captured geometry into a digital format that the computer can easily store and read.
And finally, Section 5, the future of input. What comes next?
So I want to leave you with this final thought. We've seen exactly how keyboards and mice translate our fingers, how touchscreens translate our direct physical contact, and how mics and webcams translate our voices and faces. But if these devices are already acting as the perfect translators for our hands, eyes, and ears, how will we physically bridge the digital divide next? What sense, or maybe even what thought, will computers learn to translate tomorrow? Thank you so much for exploring this with me today, and make sure you keep questioning the technology you interact with every single day.